In this video, we're going to do an example of a quadratic modeling word problem that involves a falling object. So in this question, it says a toy rocket is launched upwards. It actually gives you the height function. The height is always equal to -5 times the time squared plus 40 times the time plus 45, where h is in meters and t is seconds, seconds after launch. Okay, so let's do one part at a time. Part A says, how high is cannonball at 1, 0, 1, and 2 seconds after launch? So that's when t is equal to 0, 1, and 2. Maybe easiest to put in a table. So h of 0 is going to be -5 times 0 squared plus 40 times 0 plus 45. That's going to be 45. So 0 seconds after launch, or basically when it's launched, that's going to be 45 meters high. Okay, maybe it's being launched off a building. Then t equals 1. Again, you're going to put in h of 1. And evaluate. Let's see. Using a calculator, you're going to get 80 meters above the ground. And time equals 2. Same thing. You're going to get 105 meters. So these are the heights after those times. Now part B, it says from what height was the cannonball launched? Well, when it's launched, time is equal to 0. So the height is just 45 meters. Now let's draw a quick sketch just to help us visualize, right? So we have our time and the height. Okay, time is the independent variable, height is the dependent variable. We know that we're starting at 45 meters and we're going up, right? So 45, 80, 105. And eventually it's going to come back down again because, well, first of all, it's a rocket, it's going to come back down. And second, we know it's a parabola. Part C says, when does a cannonball hit the ground? So when it's hitting the ground, that means its height is 0, right? So we're going to solve when the height is equal to 0. So when 0 is equal to -5t squared plus 40t plus 45. You can solve this any way you like. In this case, you can actually factor it, so there's no need to use the quadratic formula in case that's the first thing that you think of. Let's notice you can factor out a -5 from everything. You're going to get t squared minus 8t minus 9. And you can factor this as well into t minus 9 and t plus 1. Now to solve this, we're going to say either t minus 9 is equal to 0 or t plus 1 is equal to 0. That tells us t equals 9 or t is equal to -1. Now, clearly, if you think about it, the rocket only hits the ground once. So what's happening here? Well, t equals 9 is the answer that we want. Where does this -1 come from? That's as if you would like extend the trajectory backwards if we're being launched from the ground. Okay. Now this doesn't make any sense because we launched it at time 0. So this is out of the domain. We're going to reject the solution. So in conclusion, it says cannonball here. It should say toy rocket. It hits the ground. Let's say 9 seconds after launch. Okay, let's do part D now. Part D says, what's the maximum height of the cannonball, and when does it occur? Remember, when we're talking about maximum or minimum, really you want to think about the vertex. You could find the vertex in a variety of ways. For example, you could complete the square. But in this case, since we've already found the x-intercepts, or the t-intercepts, I should say, in part C, we might as well use that to find the axis of symmetry. Okay, axis of symmetry, we're going to average the two x-intercepts. That's going to be 4. So that means that the maximum height occurs at 4 seconds. I shouldn't say x, I should say t, because it's time. So the maximum height we're going to say is h of 4, the height at 4 seconds. And you can put that into any form of the function. Let's say -5 times 4 squared plus 40 times 4 plus 45. That's the original standard form of the function. That's 125. So now we know the vertex is at 4, 125. If we want to write that as a sentence, we're going to say it reaches the maximum height of 125 meters above the ground after 4 seconds. Lastly, let's talk about part E, the domain and range of h of t. Remember, domain has to do with the input, which is the time, right? In this case, well, time could be any real number, but it can't be less than 0 because that's before it's even launched. And it can't be after 9 because the rocket's already hit the ground. So it's got to be in between or at 0 and 9. The range has to do with the outputs, which in this case is the height. So if you think about the maximum height is 125, and the minimum height, well, when it hits the ground, it's not going into the ground. It's not going to continue on the same trajectory. So the lowest height is going to be 0. So it's going to go from 0 to 125.